Hi. In this video, I will show you how to solve homogeneous differential equation with three constants. And I will solve three problems. So the key solution for this type of differential equation is y equal e to power rx, where r is a constant. And its derivative will be r erx, and the second derivative will be r square e rx. If I substitute these three to the original function, a y double prime will be r square e to power rx plus b y prime, which is r e to power rx plus c y, which is erx, equal to 0. I will take erx as a common factor. So erx multiplied by ar square plus br plus c equals 0. So I can divide by erx on both sides, since erx is never equal to 0. I will end up with a polynomial equation with second degree. I can solve for r using the quadratic formula, r equal minus b plus or minus b square minus 4ac over 2a. So with this type of formula, we'll have three different cases for r. So case number 1, if b square minus 4ac is positive, we'll have two roots. If case 2, if b square minus 4ac equal to 0, we'll have one repeated root. Case 3, if b square minus 4ac is negative, we'll have two complex roots. So I will give you a problem for each one of these cases. Case number 1, as I said, b square minus 4ac is positive. We'll have two real roots. I will call them r1 and r2. And the solution for this type of problem will be y equal c1 e to power r1x plus c2 e to power r2x. So let's solve this problem. 2y double prime minus 3y prime minus 2y equals 0. And I can write this equation as 2r square minus 3r minus 2 equals 0. So if a equal 2, b equal minus 3, c equal minus 2, I can solve for r using the quadratic formula. R equal minus b plus or minus b square minus 4ac over 2a. So r equal minus b minus 3 plus or minus b square, which is minus 3 square, minus 4 times a, which is 2, times c, which is minus 2, over 2a, which is 2 times 2. So r equal minus times minus is plus 3, plus or minus square root of minus 3 square is 9, minus times minus is plus, 4 times 2 times 2 is 16 over 4. So r equal 3 plus or minus root 25 over 4, and we'll have two solutions. R1 equal 3 plus square root of 25 is 5 over 4 equal 8 over 4 equal 2. R2 equal 3 minus 5 over 4 equal minus 2 over 4 equal minus 1 over 2. So the solution will be y equal C1 e to power R1x, which is 2x, plus C2 e to power minus 1 over 2x. And that is the solution when we have two real roots. Case number 2, if b squared minus 4ac equals 0, we'll have repeated root. And in this case, the solution will be y equals c1 erx plus c2 x erx. Let's solve this problem. Y double prime minus 6y prime plus 9y equals 0. R square minus 6r plus 9 equals 0. And I can write it as r minus 3 to power 2 equals 0. So r minus 3 equals 0. So r equals 3. So the solution will be y equal c1 e to power r, which is 3x, plus c2 multiplied by x multiplied by e to power 3x. And that is the solution when we have a repeated root. The third case, if b squared minus 4ac is less than 0, and in this case we'll have two complex roots. R1 equal alpha plus bi, and R2 equal alpha minus bi. And in this case, the solution will be y equal e to power alpha x multiplied by cosine bx plus sine bx. Let's solve this example. We have y double prime plus 2y prime plus 2y equals 0. So r square plus 2r plus 2 equals 0. So this is a second degree equation. I can solve it using the quadratic formula. So r equal minus b, which is minus 2, plus or minus square root of b square minus 4 times a, which is 1 times 2 over 2. So r equal minus 2 plus or minus square root 2 square is 4 minus 4 times 2 is 8 over 2 equal minus 2 plus or minus 4 minus 8 is minus 4 over 2. So since we have negative sign under the square root, I can write it as r equal minus 2 plus or minus 4 times I square over 2 equal minus 2 plus or minus square root of 4 is 2, square root of I square is I over 2. So here we will have two solutions. R1 equal minus 2 plus 2i over 2 equal minus 1 plus I. R2 equal minus 2 minus 2i over 2 equal minus 1 minus I. So the solution will be y equal, so before I write the solution, this is alpha equal minus 1 and beta equal minus 1. So, sorry, beta is plus 1. So alpha equal e to power alpha, which is minus 1 times x, into cosine beta equal 1. So cosine x plus sine x. So that is the solution.